All right, hello and welcome to 7.3 notes, perpendicular and angle bisectors. As we're getting more into the geometry in Math 2, we are being reminded of a lot of definitions and symbols and concepts that you learned back in Math 1, but some of it might be a little hazy. So feel free at any point in time if you need to pause this and look something up in a glossary or online to kind of increase and further your understanding. So here we go. Just to start off, a first necessary concept to understand is this idea of equidistant points. So we've got, it's just a point that's the same distance from 2 points. So equal, and then distance in between them. So we've got this picture here, and what it's showing is that this length AC is going to be equal to the length BC. And that happens when this line, this dashed line that you see here, this dashed like red kind of color line, that's going to happen when this line is perpendicular to line AB. All right. And when that happens, any point on this line is going to be equidistant from A and B, which is where we're going to get to in the theorem here. So equidistant just means equal distance. All right. For the next, we're going to look at two theorems here. And for these theorems, try not to get hung up on the fact that one of them's a theorem, one of them's a converse of a theorem. But if you can understand them as a whole, one package, then that totally works. That makes me happy. So what we've got here is we have this line segment XY. All right. And we have this point P. So the point they're talking about here is point P. If a point is on the perpendicular bisector, so let's have some reminders here. What does it mean to be perpendicular? Perpendicular is when you have a line, two lines, or two rays, or two segments, or any combination of those. We're going to use the phrasing two lines just to be generic. Two lines that intersect at a 90-degree angle. We call that a right angle. And then a bisector is a line or ray or segment that cuts a segment in half so that you have two equal parts. So point P is on the perpendicular bisector. In this example, the perpendicular bisector is this line PQ, which they also name letter L. So you see the L right here. So you can name it line PQ, or L is the perpendicular bisector. And this upside down T is a symbol that we use for perpendicular. So lots of vocab to be reminded of as we roll through this. A point is on the perpendicular bisector, line PQ. Then my conclusion states that then it is true that this point P is equidistant from the endpoints. So these distances are equal, right? And so we can mark congruent with these marks. So here's my conclusion. It's true that Px is equal to Py. What this book calls theorem 711 is the converse of the perpendicular bisector theorem. So it just says everything in reverse. If a point, we'll call that P again, is equidistant to the endpoints of a segment. So if Px is equal to Py, if P is equidistant to the endpoints of the segment, then it is true that this line is both perpendicular to the segment and bisects it. So what we have written here is PQ is perpendicular to XY. You'll notice the different symbols on top, right? PQ is a line, XY is a line segment. Then XQ is equal to YQ. That would be my conclusion. You'll notice they go hand in hand. One's just saying the converse of the other. Something else I want to point out is that when we write a phrase like XQ is equal to YQ, this means the lengths are equal. We can say something similar, but it's a little different, that XQ is congruent to YQ. And here I'm not talking about the length per se, I'm saying that the line segments are congruent. And congruent means that not only do they have the same measure, but they also have the same exact shape. Very similar ideas, they're used slightly differently. So let's try to use these in practice. What is the value of AD? So my goal is to find the length of this side AD. Let's look at what we're given. I have a bunch of line segments here. So that large shape that's outlined in black, I've got a triangle. Things you might notice. This height right here, AC, this line segment, is perpendicular to BD. Okay, that's what that little box means. And you may also notice that BC is 11 and CD is 11. So if I wanted to mark those as congruent, I could do that with these little slashes. From the markings on the picture, this tells me that AC is a perpendicular bisector of BD. That's what's given. The conclusion that I could draw from that, given the theorems above, is that any point on this bisector, whether it's A or some other point that I made up, is equidistant to the endpoints. So AB is the same as AD. So from here, what I can do is I could take these expressions, 6x minus 10, and I can set it equal to 3x plus 2. And this will put me on my way to find what the problem is asking for. On one side of the equation, I have a 6x. On the other side, I have a 3x. I'm going to choose to move the 3x over so that I have a positive 3x minus 10 is equal to 12. My goal is to get x by itself, so I'm going to move the 10. Oh, I copied this down wrong. There's an error here. That's a 2, not a 12. I end up with finding the value of x, which is 4. Of course, if this video is going too quick for you, please either slow down the speed of the video or just pause it and then resume when ready. All right, so I've got x equal to 4. I still need to find AD though. AD is equal to 3x plus 2. So then I can replace x with 4. Order of operations says I do the multiplication first. And I get AD is equal to 14. In this instance, there are no units provided. So I have no units to provide in my answer. It's just going to be AD is equal to 14. Did I answer the question? Sure did. Example 2. We're going to go through, I've got this kind of cool spaceship looking, kind of looks like spaceship on the top, like for a real basic drawing, kind of neato. I'm going to go through and identify everything I can for what's given to me. So let's see. AB is given to me as 10.2. So this side right here, AB, 10.2. BC, it's this little length right here, is 3.3. And BD, this whole length is 6.6. What is the value of AD? Now, I want to give you a warning in when you're dealing with these pictures. Sometimes things look congruent and they're not. Sometimes things are congruent, but they don't look it. So be careful making assumptions based on looks, because sometimes it'll work out and sometimes it won't. Yeah, just to be careful. You've got to follow along with the numbers, not necessarily what your eyes are telling you spatially from a picture. So first thing first, the first thing that I notice that I can find is I can find this length right here, CD. And I can do that by doing 6.6 minus 3.3. It's pretty easy to do in your head. Hopefully you can notice that that gives me a length here of 3.3. What does that tell me? BC is equal to CD. That means that BD gets bisected, right? It gets cut in half. What does it get cut in half by? AC. I'm gonna AC right here is perpendicular to BD. And it bisects it. So it is a perpendicular bisector to BD. I'm taking my time to write some extra notes during this because there's just a lot of vocabulary and letters being thrown around, and sometimes hearing it once is not enough. So if AC is a perpendicular bisector to BD, then we know some things. We know that any point on AC is equidistant from the endpoints. For example, point E. I know that point E is the same distance from B as it is from D. So the sides are congruent. I know that for point F is equal, the distance from F to B is the same as distance from F to D. Same thing for A. So for A to B is the same distance as A to D. So when I'm looking for my length of AD, I can get just 10.2. So that first half of the notes really focuses on perpendicular bisector. Then we're going to move into angle bisector, what that is and what that looks like. So an angle bisector is a ray that divides an angle into two equal degree measurements. So the angle bisector theorem says if a point is on the bisector of an angle, the point that this picture is talking about is point D, is on the bisector of an angle. The bisector is AD. Starts at A, goes through D. So if point D is on the angle bisector, you know that it's an angle bisector because I have these little congruent marks on my angles here. They're really small, but they're there. So AD bisects this angle, and any point on this angle bisector is equidistant from the two sides of the angle. So my conclusion is that BD is equal to CD. Now, I got to go back and explain something else here. When I'm talking about distance, when I talk about distance, I'm usually talking about like the most direct path from A to B, right? The way the crow flies, okay? So for example, I could live from point A to point B 8 miles from my work, but it might take me 12 miles to drive there. The distance is the 8 miles. It's not how long it takes me to drive, it's distance between point A and point B. Oh, there's a letter missing in that word. It is perpendicular. Let's try that again. The best example that I can come up with here is think of height. Right? If I want to measure my height, I take a tape measure, I put one end of the tape measure at the top of my height, and then I measure straight down to the floor, right? I've got to make sure that that tape measure is perpendicular to the floor. If I were to move the tape measure out, let's say I'm like, well, I'm going to put it like 2 feet over here instead, and then I measure, that's going to give me a longer height, right? All of a sudden it's telling me that I'm like 6.5 feet tall, which is not the truth. So it's got to be perpendicular. So the same thing happens when I'm measuring the length here, right? So if I'm at point D and I'm looking at this length, B to D, you'll see that BD is perpendicular to what I'm measuring to, right? So that's perpendicular because I want the straightest path. If I were to go out here, that's not the straightest path. So the converse of this says, if a point is equidistant from two sides of the angle, so if BD is equal to CD, than it is on the angle bisector. So the conclusion is that if these are equidistant, then this must create an angle bisector. The angle must get cut in half. This M in front of the angle means the measurement of, and it's talking about the degrees. So the measurement of angle BAD, I'm going to walk through you with that and highlight that. The measurement of angle BAD, so you can see that angle highlighted there, is equal to the measurement of angle CAD. Okay, so let's use that in practice. What is the value of KL? My goal is to eventually find the length of KL. Let's look at what I have first. What does the picture tell me? The picture tells me that KL is 2x plus 3 and LM is 4x minus 11. Tells me that KL is perpendicular to KJ and that LM is perpendicular to MJ. That's cool. The most important piece of information in here is going to be right here next to the letter J when it says that these angles are congruent. And I know those marks are so small, but they're there. So I've got a congruent angle and a congruent angle, which tells me that JL is an angle bisector. I know that from the marks in the picture. The conclusion is that if that's an angle bisector, then that means L is equidistant to the sides of the angle. So this means that LK is equal to LM. Well, from there, I can set those two expressions equal to each other and solve for x. When solving for x, I want to move my smaller x when possible. Get x by itself, add 11 to both sides. Have 14 is equal to 2x. I get x to 7. Now that is not what the question asked me for. So I need to go back and answer the question. What is the value of KL? KL is 2x plus 3. Replace x with 7. And I get KL is equal to 17. There are no units here. So that's going to be my final answer. Now for question 4, use the figure shown. It's got two parts, and I want to pay special attention to the fact that this part A and part B is not like step 1 and step 2. They're actually two different scenarios that it's suggesting. So because it's got the if in front, if all of this is the case, then find this. B is if this is the case, then find this. So you've got some options here. You can redraw the image that they have for you, that I have for you. You could erase and like write new numbers on it. You could scratch it out. You could copy it and take a snipping of this if you're doing it digitally. I'm just going to redraw it myself when it comes time. So here we go. I'm going to start with any piece of information that I can get from all the facts in A. If HI is equal to 7 and IJ is equal to 7, and the measurement of HGI, let's see, HGI is 25 degrees. The question that's being asked is what is the measurement of IGJ? Now let's make sure we've got some evidence to back up an answer before we just put it out there. By them telling me that HI is 7 and IJ is 7, I know that that means that these are congruent, right? They have the same length, which tells me that I is on an angle bisector. Since I know that GI is an angle bisector, I know this angle gets cut in half. So if HGI is 25, then IGJ is also 25. So when I write my answer, that's going to be the measurement of angle IGJ is equal to 25 degrees. That'll be my nice, complete, beautiful, thorough answer. Now, problem B starts with new numbers with a different scenario. I'm going to choose to redraw this, and it's not going to be perfect, and that's fine. I'm just going to kind of try to recreate it as best I can. Again, this is another example on why it's important to not take people any of the pictures, not to judge them by how they look because they could be off, especially when you redraw your own. So let's see, I have a point here. This is perpendicular. And I have a point here, and this was perpendicular. And that's the information they gave me. That was part of the original picture. Then I can add into it information provided in problem B. HGJ, so this whole angle here is 57 degrees. IGJ is 28.5 degrees, and HI is 12.2. What is the value of IJ? All right, so start breaking this apart. What do I have? What do I know? I have the whole angle, HGI is 57. Let's see if we can figure out what the other small angle is here. So I subtract 28.5. I can't subtract 5 from 0, so I have to borrow. I don't have to borrow from here. Make that 17, turn that into a 16, make that a 10. 10 minus 5 is 5. 16 minus 8 is 8. 4 minus 2 is 2. So this other angle here is 28.5 also. Aha! Now that we know that, I know that these angles are the same, which tells me that GI is an angle bisector. When that's the case, I is equidistant to both sides of the angle. So what is IJ? IJ is 12.2. Maybe that looked obvious, but it's important to know why. All right. And one last problem here. Example 5 says if the perimeter of triangle JKL, which triangle is that? JKL. So the perimeter equals 38 meters. And the length of JT is 5 meters. What is the length of KL? Now this problem does give me meters. It gives me a unit of measure, so it's going to be important that I take that into account when I'm done. Let's see, a couple of things we know. We know that JT is congruent to TL, so this is also 5 meters. Which tells me that KT is a perpendicular bisector. It's perpendicular and it bisects JL. That means any point on KT is equidistant from the endpoints of J and L. Namely, this is true. Now I can work this out in a couple of different ways, and I'm going to show you 2 ways that kind of come to mind immediately for me. The first thing I can do is perimeter means that all of the outsides are added together. I can do this a little bit in my head by working backwards. So I have 38 total. I know that this left-hand side is 10. And if JK and KL are the same, then I can divide by 2 and get 14. Another way you can do this is you could write yourself a little equation here. So I've got this whole side here is 10. So I have 10 plus JK. Let's give this a name. Let's call it A. Which means this is also A because they're the same, right? And when I add all those up, I get 38. 10 plus A, well, that's just 10 plus 2A. Got this little mini equation here that I've created and can solve. Subtract 10, divide by 2, and you'll see that it's the same work. You get the same answer. One's just a little bit more planned. So A is 14. Let's see, go back to my question. What is KL? So KL is just going to be 14, and my units are meters. In the Savas homework, if you were to leave off the units and they are provided for you, then you would not get that correct. All right.